Hello everyone. As you know that I am doing fluid mechanics previous year questions uh, from the exams like GATE, IES and IES and IAS. So today I am going to start IAS question for the topic hydrostatic forces on surfaces. Okay, I have already completed for GATE and engineering services question for this topic. Okay, so this is about myself. These questions will be helpful for mechanical engineering and civil engineering students. So the IES first question, like this question came in Engineering Services 7 and IES 2004. We have already seen this question earlier. Anyway, we'll do it again. A circular plate 1.5 meter diameter is submerged in water with its greatest and least depth below the surface being 2 meter and 0.5 meter respectively. What is the total pressure approximately on one face of the plate? Okay, so these are the options. Let's see. Anyway, see. So what is like total pressure is what is like hydrostatic force. So it is like rho g ax bar. So rho g a is what pi by 4 d square. That is d is 1.5. So we have to put this is the area, and this least greatest and least height is given. So h1 plus h2 by 2. We have seen many questions in the previous video. So please refer those videos to know about this, how this is coming. So this is nothing but x bar is nothing but h1 plus h2 by 2. So this is like h1, this is h2, so you'll get x bar. So if you simplify this, you'll get 24 kilonewton. So the answer is C. Next question. A vertical component of hydrostatic force on submerged curved surface is. Okay, so I think you can answer this question very easily. Mass of liquid vertically above it, weight of liquid vertically above it, force on vertical projection of the surface, product of pressure at centroid at the surface area. Okay, so vertical component means okay, so whenever vertical component is coming is nothing but weight. Okay, weight of the liquid vertical above it. So the answer is B. Next question. What is the vertical component of pressure for submerged curved surface to it? Okay, so it's horizontal component. Force on vertical projection of curved surface, the product of the pressure at the centroid and the surface area, the gravity force of liquid vertical above the curved surface up to the free surface. Okay, it's actually D. Okay, the gravity force of liquid above the curved surface up to free surface. Okay, this question actually very important. This already came twice in civil services and twice in engineering services. Next question. Consider the following statement regarding the plane area submerged in liquid. Okay, so the first, the total force of the product of specific weight of liquid, the area and the depth of centroid. Okay, just 1 second. Consider the following statement regarding the plane area submerged in liquid. Okay, the total force in the product of a specific weight of the liquid, the area and the depth of its centroid. Okay, the total force is the product of the area and the pressure at its centroid. Okay, see, actually see, the first statement, the total force is the product of a specific weight of liquid, yes, area and the depth of the centroid. This is what? This is hydrostatic force. So this first is correct. Total force is the product of area of the pressure and the centroid. Yes, this is also correct. Both is correct. दोनों correct है. Okay, so both is correct. Next question. A vertical dog gate 2 meter wide remains in position due to horizontal force of water on one side. The gate weight is 800 kg and just starts sliding down when the depth of water up to the bottom of the gate decreases 4 meters. then the coefficient of friction between the dock, gate and the wall. So this is also, again, we have seen this kind of question in question also. So we have to equate, the weight with the frictional force. From there we'll get the coefficient of friction. Okay, so this is I'm talking about mu p is equal to W. So P is what it is, like hydrostatic forces, that is rho g x bar. So we have to put here rho g x bar. So so this is actually rho, okay, rho g. So this g and g will cancel out. So rho g a is area is 4 into 2, okay, and x bar is like 4 plus 0, like 4 plus 0 by 2. So it is like h1 plus h2 by 2. Okay, so this is 800. So you have to solve for mu. Okay, so you'll get 0.05. So the answer is C. We have already seen not this question but this type of question in the engineering services question as well. Next question. A circular disc of radius r is submerged vertically in a static fluid up to a depth h from the free surface. If h is greater than r, then the position of center of pressure will be, okay, be directly proportional to h, be inversely proportional to h, be directly proportional to r, not be a function of h or r. So it is actually A, be directly proportional to h. Next question, assertion. The total hydrostatic force on a thin plate submerged in a liquid remains same no matter how its surface is turned. Okay. Reason: the total hydrostatic force on immersed surface remains the same as long as depth of the centroid from the free surface remain unaltered. Okay. Let's see that. Actually, the total force assertion, the total hydrostatic force on a thin plate submerged in a liquid remains same no matter how its surface is turned. No, this is wrong actually. Okay, so if we change, if x bar will change, then pressure will change. Okay, and the total hydrostatic force is on immersed surface remains same as long as the depth of centroid free surface remain unaltered. Okay, so this is correct actually. So the answer is T. Okay, so few question was, I think it is the part 1 of civil services examination. I have taken less question in this video. So anyway, we'll see more question of civil services examination. Thank you for watching. Bye bye.